Hey, it's Dr. J. I'm back with the final episode for your business calculus. So we've already talked about consumers and producers' surpluses as they relate to integrals, in particular the area under the curve. But today I want to focus on nonlinear supply and demand. Although my first example, we will have partial. One of them will be linear, and the other one won't be. So all of the examples we did in the last video, you really didn't need calculus. I mean, I used calculus as an excuse to review the integral and to show you the formulas for both of these surpluses. But you probably noticed that the areas were just triangles, right? But today they're going to be a little bit more complicated. So let's start with an example. Suppose you're given a supply function and a demand function. Where X represents thousands of units. That's our quantity. There are other presentations of this concept where Q is used instead of X. So if you look this up, you might sometimes see examples of that. We've used Q sparingly to represent a quantity. I just like to stick with the classic X variable for quantity. As long as my mind knows that it's not dollars, that it's quantity. Okay. And price is in thousands of dollars. I do have a version of this where X is 1 unit and P is $1, but then it would be, I'd have to make these numbers a lot larger. That would be 4,000. So for example, if X is 1, then this is 4 times 1, which looks like a 4, but it actually means 4,000. Right. And then keep in mind that the output, so we input quantity, and then we output price, right, for both of these. So we're inputting a quantity, and then we're outputting a price. So all of this is P, what comes out. So we sometimes write P equals D of X or P equals S of X. Why is that important? Because you're going to need to find the equilibrium. All right, the equilibrium is X0, P0. So we're going to set these things equal to each other and solve for X. Like that. So you can solve this any way you like. There's lots of different techniques. The most common technique is to set it equal to 0 and use factoring, or if necessary, some formula or some device that will solve it for you. Some calculators can do this for you. There are software programs for this. I like to put it in standard descending order. So I get x squared plus 4x equals 21. I'm going to move the 21 over. Move the 21. I probably could have done that all at once, but I'm just getting started today. So there's my equation. All right. Let me put it over here. There we go. To make it a little bit easier to read. Here we go. So first we want to find the X value for the equilibrium. Now, if you can't factor this quickly, then don't waste much time on it, especially if this was on a test and your time is ticking away. Give yourself a minute, right? 1 minute to factor it out. If you can't do it in a minute, use some other method. Use a computer, use a calculator, use a recipe. One of the most common recipes is the quadratic formula, right? You probably learned it in high school or college or something. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I only use that when I'm desperate. We got desperate a couple times back in chapter 3, right? Where we didn't have any other way to solve it. This is not really the main event here, so this should be the easy part. This is the warm-up act here. The most important thing is the signs. Yeah, it's a -3 and a +7. That way you check that if you multiply, you get -21. I shouldn't be telling you this. This is a calculus class. Check your math. Make sure it's right. All right, you're going to get 2 answers. But that's why it's important to represent the quantity, to recall that it represents quantity. So this doesn't make any sense. You can't have -7,000 units. So this is 3,000 units. All right, which we will represent simply with the number 3. This is our x sub 0. All right. And then p sub 0 should be equal to s of x sub 0, and it should be equal to d of x sub 0. I would check. Right? Check that they have the same price. So let's plug it into this, the supply function, 4 times 3, and we get a price of $12,000. Which we will just represent with the number 12. I might draw a very rough sketch of this, and I don't want to go all the way over to 12,000. I'll just put 12, and we'll understand that that means $12,000. All right, but let's double check. Make sure that if you plugged it into the other function, you would also get, so use this other function, the demand function, and make sure that you get the same price. Yep, you do. So it's $12,000. So this is our equilibrium point. On a graph, I would show it as 3, 12, but when I was talking to somebody, it'd be $3,000 units and $12,000. All right, so consumer surplus. I'm going to go ahead and do them both in this example. So remember, the consumer surplus is the area above the equilibrium, right here. All right, so I've got a S of X, D of X, and then I've got my P X, or XP, sorry. I got to say it in the right order. All right. So the equilibrium point is where they're equal to each other. In this example, it's 3, 12. My S of X is 4x, and my D of X is -x squared plus 21. All right. That picture is just to remind you what you're looking for, right, in case you forget the formula. So consumer surplus is the integral from 0 to 3, which is, again, why I'm using 3 instead of 3,000, right? I could do the integral from 0 to 3,000, but it's already baked into there that the 3 means 3,000. Of the demand, that's this. It's sort of the lid. I didn't really show it on the graph, but this point right here is 21. And then the -x squared, it's upside down. Minus the P the price with respect to X. So I like to simplify this first. You can combine the 21 and the 12 to get the 9. Positive 21, negative 12 is positive 9. And now here comes the calculus. Negative 1/3 x cubed plus 9x. That's it. That one step. The antiderivative. And then evaluate that between 0 and 3. So plug in 3 first and then plug in 0. All right. Notice when you plug in 0, you're just going to get 0. So oftentimes this step is omitted. I'm a math teacher, so I don't omit it. I write it, and I want to confirm that it's in fact 0. If you get too sloppy and you always omit this step, there's this 1 out of 5 chance where that number does not come out to be 0. Certain types of functions, in particular if they have any kind of a shift to them, where it's not 0, 0. But in this one, that's 0. Okay. All right, go ahead and do the rest of it. You're going to get negative 1/3 times 27 plus 27. So negative 9 plus 27, so 18. So this means $18,000. That's what 18 means. So that's our consumer surplus. I want to remind you what the producer's surplus is. And because the supply is a linear curve, you actually don't need calculus for this. The producer's surplus is the area under the equilibrium. So we go from 12 as the ceiling. Minus, now you got to be careful, you're subtracting the supply. I put an extra set of parentheses here just for good measure. Now the supply function is a very simple function. It's just 4x. So I can get rid of those parentheses pretty easily. However, if the supply function was more complicated, that minus 4x would be minus some more complicated expression, in which case I might want to be a little more careful when it's more complicated. So that's your producer's surplus. So we'll take the antiderivative of 12, which is 12x, and then the antiderivative of 4x is 2x squared, right? Or it's 4x squared over 2, which really means the same thing as 2x squared. And we're going to evaluate that between, again, 0 and 3. I'm just going to put our previous answer up here so we don't forget it. So that's consumer, this is producer. So we've got 12 times 3 minus 2 times 3 squared minus, and again, just for good measure, just for show, go ahead and plug in the 0, the lower limit of integration, but it's going to be 0 anyway. Oh, what do you know? It's also $18,000. Coincidence. I have a feeling because this function was linear. Yeah. So it's kind of interesting. These two areas are coincidentally the same. All right, not too shabby. I'm not going to get into the weeds as to the interpretation of this. I tried to make a good, college try at it in the last video. So for this video, so that I can get through all of the examples, I'm just going to move on. All right. Example 2. So we got demand is 87 times e to the negative 0.29x. And supply, so these are natural exponentials. Typically demand is decreasing and supply is increasing. And unless specified otherwise, X is in units, right? It's not thousands or hundreds, single units, and P is in dollars. So this one, 87 means $87, and 19 means $19, and X means whatever X means. 5 means 5. All right, so I would have to specify that it's not that in order for it to mean something else. All right, so find the equilibrium quantity or the equilibrium point. So we're going to set these equal to each other. And we want to get all our x's on the same side. So it's really up to you which side you want to go to. I'm actually going to go, which way do I want to go? I'll go this way. So I'm going to divide by e to the 0.037x. I don't really worry about the numbers right away. I really worry about the x's first. Now remember the rule of exponents. You are subtracting these. All right. I kind of regret my choice now, but I wanted to show you what it's like to make a bad choice. It's not really a bad choice. It's just not the best choice. I could have chosen something better. I'm going to add these two negatives. Had I chosen it the other way, it might have come out nicer. So had I chosen to move the negative 0.029 to the right-hand side, this might have came out to be positive. In fact, it would have. It's not too late to change my mind. It's never too late. I mean, until it is too late, and then you have to do the whole problem over again. So I'm changing my mind. I'm going to move the e to the negative 0.066 to the right-hand side. So now I have 19e to the positive 0.066x equals 87. Much nicer. Is 87 divisible by 19? This problem might be a setup. Let's see, 87 divided by 19. No, it's not. Bummer. So I have e to the 0.066x. Because these are not divisible, I'm just going to leave it as 87 over 19. I will round later. Look what it comes out to be on the calculator. 87 divided by 19. I mean, you could do it now if you like. I'm just going to wait. All right. Now I'm going to rewrite this in natural log form. Remember, this is a basic algebra concept. If e to a power is equal to a number, then the power is equal to the natural log of that number. Maybe a quick little review, cloud review here. If e to the p is equal to q, how about e to the q is equal to p? I like that better. Then ln of p is equal to q. So this is my q, and there's my p right there. All right, now I'm ready to put it into my calculator. So I've got 87 divided by 19, which I already did. And then I'm going to do the ln. Oh, they changed my calculator layout. Look, I did an update today and it changed it on me. Let's see, ln. So there's the natural log. Wait a minute. I don't trust this. It's ln of 4.57894. They changed my calculator screen on me, and I'm not very happy with that. It's making me hit the button a second time. So there's my ln now. I've hit the ln now. And then I'm going to divide by 0.066. Sorry, I'm running out of room here. And I'm going to get x equals 23.05. Nice. So it's 23 units. Whatever these things are. 23 units. Here's where some software might have been helpful. You know, you could, or, you know, maybe graph these two and find that point. Right. All right. This is an interesting graph, actually, because the supply does not start at 0 like many of our previous examples. The supply curve goes up like this, and it starts at 19. So this company has 19 units even when nobody is buying it. They've just got them sitting in a warehouse somewhere. And then the demand is kind of goes like this. And you just have to trust me with this. I'm not going to spend a lot of time plotting points and such. You have online calculators that'll show you that I'm right. I've done a lot of these. So the demand is an exponential decreasing function. And then this point right here is 23 units. Be careful. It's the x-axis, not the y. So that's our x0, I guess. Our equilibrium quantity. Equilibrium quantity. And just like the last example, if you plug in 23, these should give you the same value. So D of 23. Well, let's do the power first. So 0.029 negative times 23. And then I'll do my E. Oh, gotta clear that out. I don't like this new format. Oh, good. I can go back to the old format. All right, here we go. So I got 0.029 negative, and then I'm going to go E to that power. There we go. I like my old way better. And then times 87. 0.029 times 23, then E. All right, so that's, I'm up to here now, and then times 87. So this is $44.65. That's my P0. Let's test that the supply gives us the same amount. Now, because I rounded, it could be slightly off. That will accept a small amount of error. Let's see. 0.037 times 23. So my power is 0.851. All right, and then we'll do our E. So I'm up to here on the calculator, and then times 19. 44.49. Close enough. All right. It's because I rounded. You know, it wasn't actually 23 units, but I mean, you have to round because you can't have 0.05 units. So you're going to be, the equilibrium price is close enough. Interesting. Which one do you pick? That's a good question. Either one. Let's round to the nearest dollar. 40. This one rounds down. That one rounds up. No, rounding to the nearest cent. That's interesting. So I'll think about that and get back to you. I think it will accept. I would accept either one of these values as the price. All right, I have a tolerance programmed into the answer. I wasn't expecting them to be off by that much, but they are. All right. So let's just pick one of them. I'm just going to pick this one, 44.65. Personally, I'd rather just round to the nearest dollar, but even that's a little bit sketchy because they're off by so much. Let's see. Consumer surplus. CS. Consumer surplus. So we got the integral from 0 to 23 of 87 e to the negative 0.029x minus 44.65. All right. Again, I'm not happy with that, but I'm just gonna go with it. So we have the 87. Yeah. Now there's a whole series of steps to deal with this power, but I hope it became clear through the previous examples that all you have to do is divide by the coefficient, and then that is your antiderivative. So in other words, the antiderivative of e to the kx is 1 over k e to the kx. That should be obvious from the u substitution section. I call it u sub. So if you replace the kx, this is k stands for constant, times x, it's just going to be 1 over. Right? And then I multiplied it by 87. So this is 1 over negative 0.029 and then times 87. So there you go for your notes. So where did the 87 go? It goes outside and then it multiplies by the 1. All right. Minus the integral of $44.65 is just 44.65x. And we'll integrate that from 0 to 23. Before I erase this, I just want to make one last comment about this. The 44.65 is off a little bit because I rounded. Had I not rounded, then these prices would be identical. So if you're having any trouble with it, you can do all of the calculations first. Don't round anything until you're done, and maybe you'll get a different number than 44.65. I'm not starting this problem over again. So I'm calling it as I see it. So this is your P0. This is what I'm calling P0, 44.65, and there's your X0, 23, and that's just the way it's going to be for this example. All right. So coming up here, I've got 87 over negative 0.029 e to the negative point, and I'm going to go ahead and plug in 23. I think I already know what that's going to be. 23 times 0.029 negative. Yeah, it's the same thing it was last time. 667. All right, and then minus, again, plug in 23, 44.65 times 23. Why don't I just do that? I don't know why I'm beating around the bush about it. 23 times 44.65. Is it really that high? 1,026.95. Yeah, I guess so. So I'm plugging in the 23. Minus, now I have to plug in 0. Well, this is the reason why this particular problem, 87 over negative 0.029 e to the 0. Yeah, I know. It's negative 0.029 times 0, but that's just going to be 0. And then minus 44.65 times 0. And one of these numbers is not 0. This one is 1. This one is 1. So my consumer surplus, when I finish this all off, is going to be 87 divided by 0.029 negative. Oh, that's nice. Negative 3,000. I should have done that a long time ago. E to the negative 0.667 minus 1,026.95 plus, 3,000. It's another 3,000 times 1. That's just 3,000. All right, so here we go. 0.667 e to that power. So negative 0.667 e to that power. And then times 3,000. negative 3,000 is negative 1539.738 minus 1026.95 plus 3,000, and that will give me my final answer. At this point, I'm just going to finish it off with the calculator. So minus 1026.95 and then plus 3,000. $433.31. All right. And again, this was consumer surplus. So I took the D, the demand, minus the equilibrium. Consumer surplus. Oh, this is consumer surplus. CS, consumer surplus. For producer's surplus, that would be PS. And here's CS. Well, might as well do it while I got it on the board here. Producer's surplus. The integral from 0 to 23 of $44.65 minus the supply 19e to the 0.037x dx. Let's see. I'm going to put this up here. 433.31. That's my CS. I'm about to erase it. There we go. All right. Well, let's just dive right in. Antiderivative 4465x minus, again, it's the same thing. There's your K, 19 over K, E, and then keep it exactly the same, 037x. And evaluate that from 0 to 23. It's that same recipe again. All right, so I got 4465 times 23, which I should have just written that down from earlier, remembered it. $44.65 times 23. That's $1,026.26. I already had that earlier. Maybe this one's nice also. 19 divided by 0.037. Oh, not so nice. 513.513. Oh, that's neat. What a cool number. 513.513, 513, 513. It just goes on and on forever and ever. That's kind of cool. Kind of makes sense. Let's see. And then I'm plugging in 23 for X. So 23 times 0.037. This one's a positive power. It's going up. And then I'll do e to that power. Yeah. So this is times e to the 0.851 after I plugged in the 23. And then times this number. This 513 number. And I get $1,403.71. It's actually 72 cents. I'm going to round it later. All right. And then now I have to plug in the 0. So I already plugged in the 23 in both places. Now I'm going to plug in the 0. For the first one, I'm just going to get 0. For the second term, I'm going to get 1 times 19 over 0.037. Yeah, when you plug 0 in for x, you're going to get 1. All right, so we're done. That's the producer surplus. I already have this on my screen, so I'm just going to keep it, and then I'm going to add 1,026 and 26 cents. And then this is going to be negative, negative. So that's going to be positive. Oh, it's the same number again. 19 divided by 0.037. So many coincidences here. So many patterns you'll notice. There's that 513, 513, which kind of makes sense. It's the same value that it was right here. So you can go, oh, you know, I've already done that value. It's 513, 513 again. And so my final answer, 455. $136.06. If I've done the math right. It didn't specify that this was thousands of dollars or millions of dollars or tens of thousands of dollars. So that's our PS right there. So that's this area under the curve, which, I mean, even with a very bad graph, which isn't really the best graph here, I'll admit, I just kind of faked it here. It's reasonably sized. It's definitely smaller than the other one. All right, well, it's not the most exciting example, but at least we're getting to use the calculus, which, to be perfectly honest with you, as your calculus professor, it's the only reason why I cover this. To give us an excuse to use the area formula, the definite integral, and to give it due diligence of understanding the terminology. So that's two things you should take away from this. The terminology, producer surplus, consumer surplus, so that when I ask for it, you know what I'm asking for, and then knowing how to do some calculus. Very mild on the calculus, but symbolically complicated if you didn't. You know, if you would have just walked into this course without 14 weeks of training, this might look much more complicated than it really is. But hopefully you're all up to snuff by now and ready for the end. Example 3. All right, suppose we have two quadratics. 250 minus 2x squared and 0.5x squared. So again, like this and like this. We're trying to find the point where they cross. That's the terrible graph, but I think you'll be okay with it, right? All right. So again, supply is increasing and demand is the decreasing function. So let's find the point. Set them equal to each other. It's up to you how you solve it. I'm going to go this way. It'll be unorthodox here. Go backwards. So I got 250 equals 2.5x squared. I get x squared equals 100. I feel stupid doing this, but I don't want to screw this up. Of course it's 100. 250 divided by 2.5. I just didn't want to have my decimal in the wrong place. I've already been at this for 45 minutes, so it's better safe than sorry. So x is 10. Yeah. Technically, it's plus or minus the square root, but clearly that's the reason why the context is so important. X has got to be greater than 0. And so it's from 0 to 10. That'll be this point right here. And again, we have the consumer and the producer. Now this, we don't have to worry about them not agreeing with each other. The only one that gets sketchy is that E one. And I'll make sure that I check my answer key to make sure that there's some tolerance depending on how you round. This one has no tolerance because you're going to get an exact value. So you're going to plug in to get the price. You're going to plug in the equilibrium quantity. I should have done this one earlier. I think when you do your homework, this question will come sooner than the last one. I got a little ahead of myself with the exponential function. So look at how nice that is, 50. So that's your P0. That's this horizontal line here. You might want to double check that you get the same thing when you plug in to the supply function. Check, you still get 50. If you don't get the same number, or in the last example, approximately the same number, in this example, exactly the same number, then something's got to be wrong. All right. This is a good test question, right, where everything just comes out nice and neat. Whole numbers, are always nice when we can get them. Yeah, nice work if you can get it. All right, so let's do CS first. Consumer surplus. So 250 minus 2x squared minus 50. So again, picture helps you keep it in the right order. 0 to 10 of 200 minus 2x squared. So that'll be 200x minus 2x cubed over 3. And this is where we might end up having to get some rounding now. So we're going to get 2,000, right? We plug in 10 minus 2. Oh, nice. 10 cubed is 1,000 again over 3. So 2,000 minus $666.66. All right, this is just 2,000 divided by 3. Yeah. And then you minus $2,000 minus that is $1,333.33. I would probably round this to 67 cents, but either way, you're going to get the same, the correct result. All right, so that's the total number of dollars in the red in the consumer surplus. It'd be like adding up every possible value, right, above the equilibrium. Producer surplus is basically just as easy. It's going to come out nice and clean like this. Zero to 10. Make sure you get the order correct. So producer goes equilibrium first, minus the supply. Nice easy antiderivative of 50 is 50x. That'll be 0.5 over x cubed over 3, which you could rewrite if you prefer. That's going to be 1/6. I know I probably don't have to show you this, but my basic algebra teacher in me comes out. It's 1/3 divided, or 1/2 divided by 3, which is 1/2 times 1/3, which is 1/6. That's your fun math for the day for combining the 0.5 and the divided by 3 from the antiderivative. And then 0 to 10. I'm being kind of sloppy on this one. I'm not even bothering plugging in 0, right? Because this is a polynomial. When you plug in 0, you're going to get out 0. So I only have to plug in the upper limit of integration. It's really only with the exponentials that you would get a number other than 0 for the lower limit, an output other than 0, or if there was some sort of a horizontal shift, which could happen where it shifts it away from 0. Let's finish this off now. Plug in 10, you're going to get 500 minus 1/6 times 10 cubed, which is 500 minus 1,000 over 6. A 1,000 divided by 6. I knew that. $166.67. And then $500 minus that. And it's not too surprising. You get $333.33. So that's your PS. That's this producer's surplus under the equilibrium value. All right, well, I'm not boring you to death too much. I'm just trying to get through the types of examples that are not straight lines. None of the calculus is too hard, too complicated, but each one kind of progressively gets a little worse or a little better, depending on how you're looking at it. There are some examples with square roots. I never know whether to write demand first or supply first. There's no standard. There's really no rules. We always say supply and demand, but then when I write it, I sometimes write demand and supply. All right, let's do this one. Oh, my battery's about to die. Save me, Dr. J. There we go. Oh, you're probably hoping it would die and this video would be over, right? All right, so equilibrium point. We're going to set these equal to each other. So set S of x equal to d of x. 12 square root of x equals 3,888 over square root of x. Multiply both sides by the square root of x. So you're going to get 12x. Right? Square root of x times the square root of x is the square root of x squared, which is just x. You already knew that, but I thought I might write it on there anyway. I don't know. Sometimes you get so deep into calculus that you forget your basic algebra. So 3,888. 3,888 divided by 12. Oh, nice. I couldn't have planned that any better. Where you been this whole lecture? This was the one we've been looking for here. All right. 324 units. Now we're selling, right? Sometimes when I do these problems, and I'm not even a business guy. I'm a math guy that teaches business from a mathematical perspective. I mean, the most business I do is I watch Shark Tank a couple times a week, right? But now we're talking 324 units, right? Although I think on Shark Tank they wouldn't be impressed. They want you to be selling thousands or hundreds of thousands or tens of thousands of units. But I mean, when I do one of these problems and I get 4 or 12 or something, I'm like, oh well, okay, that wouldn't work at a high school bake sale, right? Raise money for the band or something, right? But now we're talking 324 units. Now, depending on the price of these units, will determine whether or not we're making any serious cash here, right? Or revenue. So let's go ahead and plug this in now and figure out what our price is. So we got the square root of 324, 18. And then times $12 each. All right, so there's our P0, there's our X0. So we're selling these things for $200 each, $216 each, and we're going to sell 324 of them. I'm not asking that in this section, but you're probably thinking about the final exam because it will be coming up. And if you wanted to figure out the revenue, well, now we're talking. Right now, there's a Shark Tank number there, right? I mean, suppose this is daily, right? Maybe you're selling this many units every day on the internet, or maybe it's monthly or weekly. But either way, that's some cash. Hopefully, it's not yearly. If you're only making $69,000 a year in revenue, again, revenue, very quick way to calculate revenue is to multiply the equilibrium price and the equilibrium number of units. Now, again, that's an idealized, that would be the equilibrium revenue if everything, we call that idealized or in a perfect world. And you've already learned how to do all the marginal analysis. You've learned about elasticity of demand. You've learned how to optimize. You've learned lots of different techniques. But never, ever, ever forget basic math. Number of units times the price. Boom, that gives you revenue. It's a quick way just to estimate revenue. Now, in this chapter, I actually never ask about the revenue, at least not in this lesson here. There might have been some stuff we learned about earlier that involved that revenue. I'll leave it as a DIY. You can check that if you plug in 324, that you will in fact get 216. If you don't, send me an email and say, Dr. Jordan, you didn't check and you should have checked. So our equilibrium point is 324 and 216. And now we can find our surpluses. So we got CS, integral from 0 to 324 of 3,888 over the square root of x minus 216. Right? The demand minus the equilibrium price. Now, we haven't done these in a little while, so let me show you one trick. It's not really a trick. Trick is the wrong word for it. It's a technique. It's the important technique of rewriting square roots as powers before you do the antiderivative. I mean, if you do it afterwards, that's fine, but I mean, that means you already knew the answer. So do it before and then now do the antiderivative. So you're going to add 1, so that's going to become 1/2, and then you're going to divide by 1/2. Which, by the way, is the same as multiplying by 2. which I'll do that in a second. And then this one's pretty straightforward. The antiderivative of a constant is just the constant times x. All right. So dividing by 1/2 is the same as multiplying by 2. So I'm going to get whatever 388 times 2 is. 3,888 times 2. 7,776. Now I'm going to put it back into radical form times the square root of x minus 216x. And then evaluate that on the interval from 0 to 324. So 7776 square root of 324 minus 216 times 324. You guys remember what the square root of 324 was? Was 18. So 7776 times 18. And then you get 139,968 minus 216 times 324. Oh, look, that's that revenue I just showed you. I mean, it's essentially what this tells you, right? A surplus is a revenue stream, right? We haven't taken into consideration cost. So when you think about these dollars, oh, that's interesting. I said I wasn't going to ask for revenue. Well, I wasn't going to ask it in the traditional sense, right? The R of X function. But, I mean, this does represent revenue. And it's interesting how that comes out. I want to double check my answer because I'm not sure I trust it. 139,968 minus 69,984. Oh, yeah. I just had to see it a second time to make sure it's right. So this represents that surplus revenue. Well, it's the consumer's surplus, so it's the revenue that the consumer is not giving to the producer. It's the excess above the curve, assuming that you're buying it at a lower price. So the consumer is willing to pay somewhere in this range of excess revenue to the producer. Again, I get into the interpretation and I just want to just stop and go, it's just dollars, right? It's $69,984. Let's be done with it. I'm going to do a producer's surplus DIY because I want to end this video. So PS DIY, producer surplus DIY, it would be the integral from 0 to 324 of 216 minus 12 times the square root of x dx. I got to leave something for you to work out yourself. So go ahead and do that one yourself. All right. Well, the last example is one with a horizontal shift, which I think is interesting to look at the graph of. So maybe I'll draw the graph of this. Now, the reason why this has the horizontal shift, I think, is for mathematical convenience, really, other than some sort of business economics philosophy or concept or theory. So this allows you to plug in 0 and get a value that kind of makes sense. Now, remember, this has been shifted to the left 4 units, but you can't have negative 4 units. So it basically means the supply looks like this. Yeah, there's your supply, there's your p-axis, there's your x-axis, right? But you ignore all of this anyway. You can't have negative 4 units. So I'm not sure what the horizontal shift actually means to you as a student, but when I look at it as a professor, because I teach this even in my general algebra classes, generally in algebra, I would want to see the whole thing. Yeah, I want to see this whole graph. But in business applications, I don't want to see any of that. Right? So really the supply is starting right here at 2. If you plug in 0, it's the square root of 4, which would be 2. That's kind of what your curve looks like. It's basically a straight line. It's slightly bent. Although when you get way out here, you can't tell that it's bent. You know? And then your demand starts up here at 26 and just looks like an upside down parabola. Since this is the last one I'm doing today, I figured I'd draw the curve one more time. And we're looking for this point here, the equilibrium. So we have the square root of x plus 4 is equal to 26 minus x. I saved this one for last because it's probably the most involved when it comes to solving it. I don't know if you noticed, but all the other solutions almost fell in our lap, right? Especially the last one. That was almost too easy. Example 2 was kind of tricky with the decimals and such, but really it was more of being careful than it was being difficult. This one, I mean, this involves a little bit of math here. So we start off by squaring both sides. If you haven't had algebra in a while, you might want to watch this one slowly. And you're going to get x plus 4 equals 26 minus x times 26 minus x. So the square root goes away. Right, but now you've got something a little more complicated. You're going to have to multiply all of this. I like to draw the arrows. 26 times 26. 676, and then 26 times x, 26x, and then another negative 26x. Those are both negative, and then a positive x squared. (676) minus 52x plus x squared. Now let's put all of this in standard order. X squared minus 53x. How did I get that so quickly? I subtracted 1x from both sides. So that becomes 53x. I'm also going to subtract 4 from both sides. So I'm going to get 672. And then I'm going to set it equal to 0 because all the stuff that I canceled out on the left-hand side, or I subtracted off of the left-hand side, is now equal to 0. And I'm just writing it in standard order. X squared minus 53x plus 672. Standard descending order. There is another standard called ascending, but I'm using descending. All right, now this one's tough because it's such large numbers, it's not entirely obvious how you're going to get 53. Yeah. You want two numbers that multiply to be 672, but add to be 53. I don't know. There's so many possibilities for 672. I know it has to be positive, right? Just looking at the picture. So this is an example where I'm going to use some software, right? Plug it into a solver application. Or if you don't have software, you've got the world's first piece of software, the quadratic formula. That'll always work. This is like original software. You know, it's a program that will give you the answer every time. So negative 53, negative 53 squared, minus 4 times 1 times 672, all over 2 times 1. All right, so we got 53 squared. $2,809. We got 4 times 1 times 672. 2,688 over 2. Oh, look at that. I love when that happens. Perfect square. 121 when you subtract those. 53 plus or minus 11 over 2. Oh, that's interesting. Oh. 64 over 2 or 42 over 2, 32 or 21. Sorry, I got off camera there. Come back over here. All right, come back over here. Why did we get 2 answers? I'm so glad this happened, actually. I mean, we've actually had it too easy, right? And when I was looking at the graph, I was thinking, oh man, how could that possibly be? Well, the reason is we squared both sides, right? And so we got what's called an extraneous solution. It was caused when we squared both sides. This might be the last lesson you get from me in this semester. I mean, unless you come see me on Zoom and ask any, more specific questions, but I mean, this is pretty much it. Up until now, when we solved an equation and we got a solution, that was it. That was the solution. Of course, if it was negative and it didn't make sense in the context, there were some problems where negative numbers were allowed, right? Depending on what we're talking about, like negative, you can have negative profit, you can have a negative rate of change, you can have a negative margin, right? But you can't have negative demand. This whole world lives in quadrant 1. So if you tried to plug in 32, you would end up below down here. When x is 32, the y would be 32 comma negative 12. Look, 26 minus 32, negative 14, sorry. I'm going to do it on a calculator because I'm so 26 minus 32. 26 minus 32. When in doubt, use your calculator. I'm glad I did. 26 minus 32. You're watching from home. You're like, it's not even 14, Dr. J. It's 6. Either way, it's below the water. It's below ground. It's below the x-axis. This is extraneous. It doesn't make any sense. Right? You can't have a negative demand. Right? It also doesn't make any sense for this. Yeah? Because if you plugged in S of 32, you would get the square root of 32 plus 4, which is the square root of 36, which is 6. It's not negative 6. So that's not the same. Remember, supply and demand have to match at this particular point. So why am I making such a big deal about this? Well, because this hasn't happened very often. And so it is a big deal. You're going to get two answers, and you need to know which one doesn't make sense. It's not always the larger one, by the way. Although in this example, it is the larger one. In general theory of algebra, it could be either one. It's whichever one does not cause a match. Right? Whichever one of these does not cause these to be equal. And so I plugged in 32 into both of these equations, and they did not match. So that means 21 is the only one that makes any sense. All right, and then you could check if you plug in 21, you're going to get a supply price of 5. Call that P0. The demand is 21 units. We got rid of the 32, didn't make any sense. So that's our X0. And you could also check the demand at 21. It's also 5. Check. So there you go. And now you can find the consumer surplus. Integral from 0 to 21 of 26 minus x minus 5. Right? Consumer surplus, you take the demand and you subtract the equilibrium price. So that would be the integral from 0 to 21 of 21 minus x. Well, that's interesting that these match. So it's going to be 21x minus x squared over 2. 21 times 21 minus 21 squared over 2. (21 squared divided by 2). So it's 441 minus 220.5, which is exactly 220.5. Again, you will notice a lot of patterns, especially with square roots and squares and things of that nature, because it's a quadratic, right? It has that kind of symmetry to it. And remember, when you're doing consumer and producer surplus, it's essentially the numbers you get are revenue values, or at least either lost or not earned revenue, or given up revenue. If you think about it, it's like the producer is saying, look, I'm willing to let this amount of money go in order to sell more units, right? Or the other way around, the consumer is willing to pay more than the equilibrium price. I think it's great if you think about the psychology behind it. They think they're getting a sale. It's like what's happening. I don't know when you're watching this video, but I'm filming this video right around the Cyber Monday online sales extravaganza, right? And millions of people out there shopping online right now, and they're thinking they're getting a deal, right? But you could be paying above the equilibrium price, right? You're in this area here. So this 220.5 is in this area here. And all they got to do is tell you that it's 40% off, and that you don't even realize that you're buying it in this area right here. Or the other way around, the producer's surplus, which would be this little tiny wedge right here, although my graph is not to scale. Producer's surplus, integral from 0 to 21 of 21. Oh, sorry, not 21. 5. I forgot it's on my graph here. 5. 5 is the equilibrium point, right? It's 21 comma 5. I didn't draw it in my graph. So it's 5 minus, now I got to be careful, the square root of x plus 4. And I'm not allowed to combine these. So I get 5x minus x plus 4 to the 3/2 over 3/2. Remember the antiderivative of a square root? It's like x plus 4 to the 1/2. I am supposed to do a u substitution. U is x plus 4, and du is just dx. So if I have u to the 1/2, the antiderivative is u to the 3/2 divided by 3/2. And then I switch back to x plus 4. Oh, I'm getting tired. I'm going to try to finish this and just call it a day. So I've got producer's surplus is 5x minus 2 times x plus 4 cubed square root over 3, evaluated from 0 to 21. This is the fancy way of rewriting 3/2 power. I'm writing it as a square root cubed. Oh, and there's a big 2 there from this denominator. 3/2 gets flipped, becomes 2/3. And now I'm going to plug in 21. And I'm also going to plug in 0. Yeah, because of the shift, horizontal shift. If I plug in 0, I'm not going to get 0. I'm going to get a number. So 5 times 21 minus 2 times the square root of 25 squared, cubed. So square root 25 and then cube it and then divide it by 3. If you're still watching and you haven't gotten completely lost, slow it down and just go through step by step. I'm going to plug in 0. So 5 times 0. That one's going to be 0. But then this one's not going to be 0. It's going to be the square root of 4 cubed over 3. And that, my friends, will give us our final answer. So I have 105. I could probably do all this by hand. This reminds me of an old school calculus question. Square root of 25 is 5 cubed over 3. 5 times 0 is 0. Negative times a negative is a positive. Square root of 4 is 2. 105 minus 2 times 125 over 3 plus, the 0 doesn't matter, 2 times 8 over 3. 105 minus 250 divided by 3 plus 16 divided by 3. Put all that in the calculator. 250 divided by 3. That's $83. Negative $83.33. Plus 16 divided by 3. So that's negative $78 for my final answer. $27. That's my producer's surplus. Which kind of makes sense if you think about the graph. It wasn't a very great graph, but that was a tiny little sliver underneath the curve, underneath the equilibrium line, that was only worth $27 in potential lost revenue for selling it below equilibrium. That's kind of what that means, right? It's all the possibilities, all the possible prices and demands up to that equilibrium point. Well, you're probably exhausted. You've worked really hard this semester. I'm exhausted. You've earned it. You're done with the course. If you have any questions, email me. I'll be happy to answer them individually. If you need to see me online, make a Zoom appointment, come say hi or bye. I'll be posting all the last homeworks, and the final exam will be coming up soon. So until we meet again someday, I'm Dr. Jordan. Don't forget, I'll see you on the internet.